Okay, so I'm Glenn, and this is Joseph Nelson here. So I'm Glenn from Ultralytics, the YOLO V5 guy, and this is Joseph Nelson. He's the CEO and founder, co-founder at Roboflow, and we're here to talk about YOLO, about AI, and a few things that are going on in the industry, a few things that Roboflow and Ultralytics have put together, and some exciting roadmap, I think, steps that are coming up in the near term. So. All right, so thanks for joining us. And yeah, all right, let's just jump into it. So YOLO V5 has been out for a couple of years, and Roboflow has been doing amazing work in the dataset space and also helping people train models. And I think the two put together are a pretty powerful combination. And we're here to show you how some of that works and to show some really cool new tools that we've been building to make training models, make deploying them, and getting started from all the data sets that are out there on the Roboflow universe, even simpler. So we've got a bit of a walkthrough that we're going to show you here. And we've also got a Q&A. So just feel free to leave any questions that you have here for us. And we'll get to those and we'll try and answer as many as we can. So, okay, so let me see here. So we're going to share our screen. And Joseph's working on that right now. So I'll talk a little bit about YOLO though. So YOLO has been going under some significant improvements this year. We have been adding new tasks, most notably classification and segmentation with our latest releases. And segmentation in particular is very performant. It tops the tables on papers with code for the SOTA benchmarks for real-time instant segmentation on the COCO dataset. This is really exciting. This is like one of the first times that we've been one of the most accurate in the world. In the past, I think a lot of the effort that I put into YOLO V5 in particular has been making it easy to use, making it easy to get started, and helping provide tutorials, walkthroughs, and of course, answering lots and lots of questions and lots of issues on GitHub, which is where I spend most of my day. Just there kind of improving things, getting a pulse for what's going on in the YOLO world, feeling people's pain points and trying to address those with the 24 hours that I'm given in each day. So, okay, let's see, okay. All right, let me see here. So we'll do a bit of a walkthrough on my computer then. So let me share my screen here and we'll get started. So, okay. So close a few windows here. Okay, so I'm a PyCharm guy, by the way. So you get a lot of flack for that, but I don't know why. I don't get VS Code though, but you know, to each his own. So okay, let's go to the YOLO V5 repo here and we'll take a look. So right here with Ultralytics / YOLO V5. If you're not familiar with it, you just Google YOLO V5 and this will be the first thing that comes up. We've got this this fancy new V7.0 release. And this indicates a new release of YOLO V5. So V5 is constantly growing and updating, and V7.0 is the latest release. So this is a bit of a confusing naming convention, but it's how we indicate the very latest version that is out that you can use. And like I said, the main update here is segmentation. So compared to the SOTA models that we see out there in the rest of the field, we are this blue line. So we have models that are more accurate and faster. And these just came out a few weeks ago. So this is really recent news. And I think the biggest thing for me is that these are just as easy to use as all the other models that we've made. So detection has always been our hallmark. And as we moved into segmentation, we didn't want to sacrifice simplicity and accuracy. And we wanted to try and make this as simple as possible. And so we've created a Colab notebook that'll get you started with quick start tutorials for training models, running inference, running validation. And the data sets and the models on this notebook and in all these examples automatically download the first time you use them. So it makes everything super easy. You don't need to go and find any models. You don't need to go and download any data sets. You simply run the commands here and the models will automatically download from the release assets that we have here on GitHub. And the data sets will automatically download also. And these are somewhat toy data sets. These are data sets like COCO 128-seg, which is a really small version, sort of like a sampler for COCO segmentation. And of course, once you want access to a wider variety of data sets, and of course, to upload your own data and to annotate that, that's what we have the Roboflow integration for, to make that super easy and with single-click export to the YOLO v5 format, including for segmentation. Okay, let's see, Joseph, did you get signed in? So it looks like you did. Okay, oh, wonderful. Okay, so now we've got, let's see, Joseph here, and he can jump in and start sharing some of the Roboflow part. So,
yeah, I mean, I think, so some context. Hey, everyone, Joseph, co-founder at Roboflow. We've been excited to partner and accelerate YOLO v5's adoption as being one of the easiest ways to get going with computer vision. And we've been excited that it's expanded from object detection to classification, segmentation tasks.
yeah, definitely.
You can't build a good model without having good data, and you certainly can't build a good computer vision system without being able to quickly react to where your model's failing, identify places for improvement, solicit more of that data, relabel, retrain, redeploy, and follow a really successful iterative loop.
It's definitely all about the iteration. You definitely want to approach the problem as sort of a living, breathing system where the first training that you do is simply the first pass, and you improve upon that, and you keep improving upon that. You identify weak spots, you source more data, you annotate that data on, for example, edge cases, like maybe dark images aren't working well, and then you retrain, you redeploy. That's very important. And I think the most successful players in the space build tools and build products that kind of have that at their core.
Exactly right. I mean, the former head of AI at Tesla, Karpathy, recently had shared some thoughts on this exactly, where he said, one of the advantages of Tesla is not only that they have such a large number of vehicles out in their fleet, understanding images out in the wild as they solve autonomy, but actually how quickly they're able to use that data to identify places where the vehicles are failing to adjust to conditions successfully. Edge cases, different forms of things that you need to see, being able to improve. And that relies on a lot of different moving parts. It relies on, sure, having a very successful model, equally relies, if not more important, on how quickly you can find failure cases, identify how to label those failure cases, relabel, retrain, improve, redeploy, and then assess results and continue and start that feedback loop over and over again. And at Roboflow, I mean, we've seen tens of thousands of models trained and hundreds of thousands of data sets created, hundreds of millions of labeled images throughout the community.
It's a lot of images.
And so we have pretty good context into like what creates a good computer vision system, what creates a really powerful data set, what allows you to get the best results possible. And this is one of the reasons that we're big supporters of YOLO v5 and affiliated projects, as well as a wide array of models to empower users to do what they need to do to be successful. I thought maybe what could be useful is we talk a little bit about some of the integrations that we built for some of the core YOLO v5, what's shown on your screen here, Glenn, as well as some of the new stuff that we're releasing and introducing today in the form of Ultralytics HUB and Roboflow for creating another way for training and deploying models.
Yeah, absolutely. I think I've done like a tremendous amount of work on making things simple, because that's always been a big pain point of mine ever since I got into AI. For me, it was really confusing, and the ramp up was particularly painful. And so I've sort of like taken that into heart, and a lot of the actions I take here are making things simpler. And HUB is a new way that we're providing a low-code, no-code tool to train and deploy YOLO v5 models. It's a bit of an experiment since we're mostly focused on open source, but it's a logical next step to make things even simpler for people that are looking to just click a few mouse buttons rather than run some lines of code.
And at Roboflow, wherever someone wants to use their data, use the models to be successful, we think that we should empower those sorts of use cases. And so, for example, by leveraging the vast amount of open source imagery that people have labeled, tooling that we've built for understanding your data sets, labeling tools to automate labeling and be able to prepare data more quickly, versioning data sets so you can quickly understand how one given model performs in a given data set, and then train in a variety of different ways, both train with perhaps you want to have like a quick AutoML check to see what's the quality of my data set, what's my initial sense of results, how do things look, and then also a way of training of a code-centric way of I want to use a given architecture, I want to use faster RCNN, YOLOX, YOLO v5, any array of model that's going to best produce the results that someone's aiming to do. And then once they have that model ready, being able to deploy it and scalably deploy it, because training a model once and deploying it scalably are kind of different problems. Like building a web service versus building like a web service at Facebook scale are very different things, right?
Right.
And so the same thing applies in machine learning as it relates to scaling up anything from a web hosted model to a deployed model. Maybe what I could do is go ahead. Yeah, if you're gonna talk about that.
No, I was going to say you're absolutely right. And this reminds me a lot of my background in physics. And so when I was in physics, I did some really cool stuff. But a lot of it was just in the laboratory, and I always wanted to take it out and put it into the real world. I wanted to create an actual product that would affect everyday lives. And I wasn't really able to do that in high energy physics. But out here in AI, I've also taken the same approach and made the same priorities. And so for me, it doesn't make sense to train a model that performs really well on a benchmark data set. But then if you can't export it, if you can't drop it into a product, scale it quickly, like you said, then I think if there's no light at the end of the tunnel, then a lot of the motivation for me sort of disappears. And so I definitely agree. I think being able to deploy your models, export them to the formats that you need to, and of course, scale those deployments is incredibly important. It's not something people think about at first, but I think it's something that you have to keep in mind when, for example, you're choosing architectures and you're building a workflow.
So maybe what I could do is I could screen share over here and show some of the integrations that we have both within the repo and then maybe with like Roboflow and HUB in some of the ways.
That sounds great. Yeah.
So I'll share over here, but I'll continue speaking
over here.
Okay. Yeah, because I don't want to double up on that guy. So yeah, I mean, I guess just picking up from like the YOLO v5 repo, a few things. One is that like if someone today wants to go train a custom model on their own data set, they might find themselves on the train custom data repository. And you'll note that, of course, to train custom data, you need to have custom data.
That's right.
You have your own labels.
Data is important.
Data is pretty key to be able to train.
You got to start somewhere. It's true.
And so the ability for sourcing data sets could be everything from like maybe a user is collecting their own images, or maybe they're going to like Roboflow universe where there's hundreds of thousands of data sets of everything from like pickleball to tennis to everything in between. And
yeah, the thing I like about this is the crowdsourced nature. So you get actual data sets from real world use cases.
100%. And so like there's example models and data sets that people have tried and trained on. For example, this one's like a fun trained like pickleball model. But this data set you could just take and use in production. So you could go ahead and take this and download it in a YOLO v5 format and export it and use it directly into a custom training pipeline. But let's say that like maybe your data is really unique and there's not like anything like it in the world. Maybe you're like manufacturing a brand new item that no one has ever seen before. Well, then you of course
you got widgets and you want to inspect them, and their widgets are pretty unique. You're not going to find a data set with that.
Maybe you're the only one in the world making, I don't know, AirPods. You're a certain company that does that. Then you're the only one that knows what AirPods should look like, almost by definition. So you collect your data, and then you need to do some amount of labeling and improvement of that data, which we can show more about that in a moment. And then you can version and create and export that data set and then use it directly with a code snippet that Roboflow provides to just copy paste and use directly in your custom training pipeline. And this is sort of like the most common way that people are using Roboflow and YOLO v5 together today. I mean, there's open collabs that people can follow along, and this is probably if anyone's on this webinar, they're probably familiar with and have followed this exact process
probably
many times before. But what's kind of new, and what we kind of wanted to introduce today is with the release of Ultralytics HUB and the promotion of kind of a low code, no code way of training models, potentially users want to use Roboflow and not just the code first way of YOLO v5. Maybe we'll use Roboflow and HUB together. And so we've kind of got an example that we could walk through of what that might look like.
Yeah. So this would be an easy way to train YOLO v5 models without ever touching a line of code. So for some people, that's pretty appealing. For some people, they really want to get their hands dirty. They want to look at the details. They want to really change everything. And so I think having those two options, having the GitHub repository that you can clone and have unlimited freedom to change however you want, and at the other end, having something that's very simple, literally with just a few clicks of a button, you could end up with a trained model. I think covering those two extremes is a great way to start, and filling out the middle also but I think that covers like a wide variety of use cases. I've always said my end goal here is to make something so simple that my mom could use it. And I don't think we're not even close, but we're heading in that direction. I think Hub is a tremendous first step towards that.
So let me maybe walk through like an example of like a problem that we want to tackle. So here in Roboflow, like I've just created like a sample like kind of workspace, and I just called it the Roboflow Ultralytics webinar. And here, I can create a new project, and I guess I can show like if you create a project, you go here and we're going to detect chess pieces, and we'll call this chess project, and we'll give it an open license. And here, of course, I can upload images either directly maybe from like a YouTube URL, or maybe I have the images locally, or maybe I'm going to go to Roboflow Universe or one of these places, or maybe I just already have the images available to me locally. And so here I actually already do have some chess pieces and examples of what those chess pieces might look like in context. And so I could just, go ahead and drop those in. And I realized that I've actually already done, well, I guess I can show that I've already dropped in some of my images, and maybe some cases I already have labels, maybe I don't. So if I don't have labels.
So how many images do you have here in total?
Here's just a small, like, should be 20. I think I grabbed all but one.
So you've got about 20 images, but many more examples of each piece in each image. So
that's right.
So a lot of more instances than images.
That's correct. Yeah, because there's like a chessboard with multiple pawns, and this model will probably struggle on like kings, queens, or things like that. And there's a much larger data set actually that I painstakingly hand annotated of a few thousand chess piece images. It's just for the sake of a demonstration, I like to use a smaller data set so things go quickly. Now I've actually,
I think small data sets are a great way to get started. You're obviously going to want to augment them and improve them for production usage, but I think just to get a feel for what the technology is capable of and just get an initial result, small is the way to go. And also, of course, for capturing any bugs in your workflow, a bit of a sanity check is important before you really kind of like dive in with like a week-long training on a massive data set.
That's exactly right. And so like here, I could divvy up and say who's going to label what, and I can invite my friend Glenn. I'll just say Glenn at YOLO so that I don't give your email to everybody. You can invite my friend Glenn and have him go ahead and actually I'll do YOLO v5.
YOLO.v5.
And we could label some things together and assign images and this sort of thing. And
this is cool. So we can separate out annotation tasks. Like I can do some of them, you can do some of the other images.
Exactly. Exactly. Now I've actually gone ahead and I've got a different one called chess detection where I've already got going on this. So I'll jump on over to this one.
Cool. And this is with the same data set that we just uploaded?
Yeah, this is the same data set that we had just uploaded. Well, actually, I only annotated 18 of them. I deliberately left 2 of the images not yet labeled because I want to show what happens with the hub and Roboflow integration. When you have kind of unlabeled images. So, so with my data set, the way that it is, and why don't I just delete the other projects because it's a little confusing having 2 doing the same thing. I'll get a confirmation step.
So when you delete a project in Roboflow, does it end up in a trash can or does it simply disappear?
You have to do double confirmation as you saw me do quite quickly, and then it deletes. Yeah, because you don't want to accidentally delete things. You want to like double opt-in confirm. But cool. So I mean here I've got my my data set. And before the webinar started this morning, I actually just kicked off a train job that's been running in the background.
Yeah, that's right when it started, actually.
Exactly. So kind of
wait till the last second.
Exactly. Well, actually,
you know why I do this last night?
Well, no, I actually wanted to show as
it's a new feature.
Yeah.
Cool. Yeah. So this is training live right now.
That one's training live.
Oh wow. Okay, cool. That's very impressive. And we are on epoch 332. How many epochs are we training?
We're gonna go until there's no more progress.
Oh, okay. So this is the patience, basically. Like So patience is how long you wait with no progress before you just give up. So YOLO v5 has a default patience of 100 epochs, which means if you, let's say, train for 200 and you haven't seen anything better since epoch 100, it just calls it quits to save you resources and let you free up those for another training. But so in this case, it looks like we're still improving, and that's why it's still going.
That makes sense.
Yeah.
So in the context here, though, let's pretend that like I want to use the new hub integration. So I've got my data set. I've labeled 18 images. I'll generate a new version. I won't use any augmentations, and I'll just create this one here.
Yeah, no augmentations can be actually beneficial for small data sets and short trainings. So it's only when you get to larger data sets, longer trainings, that you really have to introduce them to prevent overfitting or at least delay it.
How do you think about maybe like augmenting like, underrepresented classes compared to like overall data sets? Like we get this question a lot. I mean, in chess, it's hard because like you're never going to find, for example,
augment the queen.
Yeah, you're never going to find a chessboard where there's
equal numbers of pieces.
Equal numbers. I mean,
at least not at the beginning of the game.
Certainly, you're going to struggle.
Maybe,
You'll struggle.
Well, so that's a good question. So oftentimes instances are of course embedded in image, and so for example, for this chess piece, since we just have a box label rather than the segment label, we could copy that and paste it in other parts of the image, but you're going to copy some background with it too. If you had segmentation labels for the queen, for example, you could put maybe 10 more queens, and then you'd have the same number of queens as pawns. So that would definitely improve detection of queens. But I think it also depends on the length of the training. I think if you train long enough, a lot of class imbalance tends to resolve itself as long as it's not too extreme.
What would you find is, what would you think is too extreme?
Not 10 to 1. 10 to 1 actually is not that extreme. So in the COCO dataset itself, I think the most represented class compared to the least represented class is I think 3, maybe 4 orders of magnitude. So
like I think 4 to 1, for the most a person, and then 1 of like
no, like 4 orders of magnitudes and like 10,000 times more. So for example, I think hair dryer. I think there's only like 100 examples of hair dryer, but I think for people there's almost 1 million or so, or maybe 100,000. I forget which order of magnitude, but that means that there's 1,000 times more people than hair dryers. But still, when you look at the result, the detection result and the accuracy between the two is not that different. It's obviously better for people.
We had a question that came in during the webinar that is maybe related to this, that'd be fun to ask. What is the maximum number of classes that you think you could include in a detector?
Okay, so once you start getting a lot of classes, you want to structure the output head differently. You want to have categories and then subcategories. So that, or at least like combinations of outputs that would turn into unique classes. So if you had, say, like, for example, like, and that happens, like, let's say you're Walmart and you have 100,000 products. You don't want to create a YOLO model with 100,000 classes, but you could create a YOLO model that combines outputs in a binary sense or in a digital sense to classify classes. And this is an example of what YOLO 9000 did, which was actually what YOLO v2 was supposed to be called. But Joseph got like kind of interested in this topic, and he actually created a YOLO model that can do 9,000 different classes. And that's been a few years since he's done that. So there's different approaches. I think once your class count gets significant, say like over 1,000 classes. But yeah, that's an interesting question, and not one most applications usually face. Like typically what we see is really low class counts is the norm. Even things like 1 or 2 classes probably dominates most trainings. And of course, there's an exponential distribution, and the long tail is something like for a few thousand classes, like I think for inventory for the most part, for stocking shelves and things like that. So there are use cases with a dramatic amount of classes, but that typically requires a different approach.
Right. Without changing the head of YOLO v5.
Yeah, without changing. Yeah. So, okay, well, another thing about AI is that there's no hard failures. It'll just perform slightly worse and then slightly worse the more classes you add. And so it was really hard to say exactly like how many classes you can train, because it's a sliding scale. It's really up to you what kind of accuracy you're willing to accept. So if you're okay with poor accuracy, you can put a few thousand classes. If you demand high accuracy, then you probably want a different approach. So
yeah, we've also seen, like, if you don't want to change maybe the heads of the architecture itself, perhaps what you do is you actually structure the class ontology differently. So you do like hierarchies.
Yeah,
so you do like
exactly.
neighborhoods of products, which I mean functionally is what I understand the head that you're changing.
The
network is doing. Yeah. But you could do this maybe even more like I would call it like,
you could have a cascaded approach where you roughly classify. Like you could say this is a fruit, and then you have a second model that looks at those and classifies the fruit. Because once you have a fruit, then you can't have 1,000 different types.
That's right. Yeah, so we'll see some of that too.
At least I'm not familiar with 1,000 types of fruit.
Yeah, but that's an approach we'll see. Where
I haven't traveled around the whole world.
How many fruits are there?
There's some. Once you get to Asia, there's some weird fruits out there. I've never seen. There's even fruit that they don't eat. It's for like ornamental purposes. So, okay,
learn something new. Learn something new every day. So, okay, so we got
Right.
to the point here, we've got like
Okay.
this small data set, we've got like, 12, 4, 7 images in our train test split.
Okay.
Now let's say that I wanted to, so I could train this directly with, for example, like, we'll show Ultralytics HUB in a second, but
Okay.
maybe I want to use like the yes code way.
Mhm.
And so what that does is it basically zips it all up and gives me a hosted link that I could grab and use this directly in my custom training notebook. So
Okay.
like if I'm,
So you just copy that snippet of code and you paste that in the custom training notebook.
that's right.
Okay.
So if I'm here
Mhm.
and I scroll on down to the portion where I'm ready to load my data,
Mhm.
I can just copy this
Mhm.
and paste it, route it into here.
Okay. And then the same code will now train on this new data set.
Exactly.
Yeah.
Exactly. I mean, actually, this is the cell that I replaced it.
Mhm.
But like, as you mentioned, maybe you don't need that finer tuned granularity. Maybe you just want to quickly get a result. Maybe you don't want to be concerned with, do I care about patients? Do I not? Do I care about like image size? All these sorts of things.
Mhm.
So in that case, maybe what you do is you want to do a training directly with like a no code way,
Mhm.
like Ultralytics HUB.
Mhm.
And I think you might be authed rather than me. So it'll go ahead and pull this data set directly into, this is your account.
Hey, it's me. Yeah.
Directly into the your HUB
All
account.
right. Yeah. So I see now we're in HUB here. And so we're in my account. This has got Glenn here. And we've got our chest data set. So we just click that import button. And now we're seeing it right here in HUB. Okay. Oh, yeah. Now we can see actually how many queens do we have?
You can explore things.
Got 5 queens, but 55 pawns. Yeah, it sounds like the right ratio.
You think so? Is it past the smell test? Yeah. I mean, let me double check and see how many do we have. I should have checked before we did it. Yeah. So
okay.
we had, like 3 queen, 5 queens.
So black's got more pawns than white. So black's doing a little better at this stage in the game.
At least when we have. Yeah. So I mean, we can see that similar sort of stuff here. And then what's nice here is actually, if you click these, it actually allows you to see that specific split. So there I click the validation split.
And then it takes you back and then it looks at
the images that were in my validation set, the ones that were in my train set. So again, 12 images in my train set, my test set, there was only 2.
Yeah, that makes sense. That's about right.
So I've got my data set here. And we promised like a no code way of training.
Right.
So
we just click that train model button in the top right. We've got our data set.
And then
click continue.
Yeah, and we're trained version 1. That was the one that we just sort of had as an example. So I can go here and click continue.
Okay, now what we see is all the different YOLO V5 models. So V5 has 5 standard models for the different sizes. So we've got nano, small, medium, large, and extra large. And then we've also got these 6 models, and these -6 models are suitable for really large images. They're much better for detecting large objects. So since we have a chest data set, we're not detecting large objects. So I would start with a nano model just to get initial result. This is the smallest and the fastest model, and you'll get an idea of how well you can train just within maybe 60 seconds or a minute. So here we have different ways that you can train. So Colab is super popular with students. I love it. I actually do most of like my quick tests on GPUs in Colab because I don't have a local one. I just have a MacBook Pro. So to train on Colab, you click this button and this takes you straight to the HUB Colab notebook. So you'd run this setup cell, and then you take this API key that we give you, and this identifies the model, and you just go down to the second cell. There's only 2 cells in this whole notebook. You paste that key, and then you run the second cell also. And this will start downloading that chest data set from Roboflow, downloading the pre-trained nano model from Ultralytics HUB, and it'll start training. And the default settings are for 100 epochs, which for a small data set will typically complete in maybe just like a minute or 2. And then that will send that model back to HUB, and you can export that into all the different flavors that you can with the repository. So these are formats like OpenVINO, Onyx, CoreML, TF-Lite, other TensorFlow formats, TensorRT to accelerate on GPUs. So this really opens the door to like a lot of export formats and a lot of deployment destinations. So once that's connected, you just click done, and that will take you to this models page. And so here you can see your training progress. So since this hasn't started yet, we're at 0%. But you can see the first epoch just got started here. So we just trained the first epoch, we validated the first epoch, and now we're just going down the list through 100 epochs. So we just crossed epoch number 9 and 10 here. And so this is really just going to be done in like 60 seconds. And so we go back to Hub, and we can see the training is 16% complete. And we can start to see map increasing here, and map being the mean average precision of the different classes. And oh wow, so it looks like some of these numbers are like already in the 50s. So I think by the time we get to 100 epochs, we're going to have a model that is actually not too bad. So we're watching like real time a YOLO model train on a Roboflow data set. We haven't had to write any code. We've just like clicked a few buttons, looked at some nice pictures, and really just waited about 60 seconds here, which I'm not even sure if that's fast enough for me to get another coffee. So, so we're really like accelerating workflows. We're kind of like delivering like really fast, really cool experimental results that can give you a picture for how well this model works. And then you could, for example, train a small model, maybe see the trade-off in size, speed, and accuracy. And this is how you get started then. So
it's super exciting.
Yeah,
it's
exciting.
Just, and then
it's really cool.
And the nice thing is that this allows you to also have the model become available back into, as you mentioned, export formats, but also when you opt in to have the model available for automated labeling.
Yeah.
So you can see that you can continue the workflow that we were talking about.
Which is where we get into that iterative loop. Yeah.
Exactly. So like when you kick off a training here, the model becomes available to use for automated labeling directly back in your Roboflow account.
So the right thought process is, okay, the model is done training, but that's actually not the end. That's just the beginning. So this is really where the game starts. And now the game is to improve your results. You want to trend towards 100% accuracy. You're never going to get there, but it's okay. That's the way you want to go. It's sort of like the mirage on the horizon. And the closer you get, then the more viable your product becomes, and then the cooler things that you can build, and like the more you are on your journey into AI.
So why don't I so I'll go back into Roboflow here, and actually like why don't I go to some like universe data of like chess pieces. And I'll search for chess piece data that might be able to use to improve mine. And I'll search on metadata because I think that I know a data set that is, yep, here we go. So there's lots of these chess piece images. So like, let's pretend like, oh, I want to go here and I want to get more images. And while these are labeled, let's pretend like I want to grab them, and I didn't like the labels that were here, but I want to add these to my data set.
Okay. So
I'm going to like grab some of these images. I'm going to be like, yep, that one looks cool. That one looks cool. That one looks cool. I don't know. I'll just grab like these.
Okay.
These images, and then I'll clone those, and I'll bring them into the Roboflow and Ultralytics one, and then I can put them in a chest detection project, and I'll import the raw images. I don't want the
annotations.
Yeah. So I'll finish cloning those 8 images, then I'll go to those in my project. Okay, great. So now I've got some images that I hadn't labeled yet in my project, and we can demonstrate what it's like to use the model that I've sent back for continued improvement and continued labeling along the way. So now
we can use that model to auto label some of these new images that you brought in that are missing annotations.
That's exactly right.
Okay.
So here was the 2 that I did at the very beginning that I kind of ignored. And then here's the 8 that we just brought in from that other project on Universe. And by the way, it's not coincidence that this data set, or that the chess images here look familiar. I initially labeled some chess images, but this is also the US Chess Federation, like official.
Oh, is the official board really?
Yeah, board that they use.
I thought it would have been a little nicer. Like a nice like hand carved. I don't know.
I mean, it's very approachable. And there's
it works.
Yeah, there's no. Yeah, there's no surprises, no sort of
So
stuff.
the budget isn't really there for a nice chess set.
Okay, so then I'll like come back in here, and okay, so now I've got these images, and again I can assign them to myself for labeling. So you'll see actually that in that annotate tab now there's like 2 jobs. There was the very first one that when I started before the webinar, I created the data set of 18 images, and I said leave 2 unlabeled, and now we've got this new one of additional images that we grab just from out in the open of these 8 images.
Okay, so are these in a queue then? Like one's waiting until the other one finishes? And
well, actually, you can start them. You can start them in whatever order you want.
Okay.
Yeah. Okay. I mean, I'm the labeler for both, so like it didn't really save myself a whole lot of time. Maybe we should make you label one of them, and
Okay.
You could decide. But yeah, I'll jump on in, and so actually one thing that we didn't show earlier that I do kind of want to show is we actually have like this like smart polygon labeling that I could use by default.
Yeah, I saw that before. That looked really cool.
So like this sort of thing, and then like you kind of like make it be a little bit tighter and say, no, like I want you to.
So you iterated a bit until wow, okay, you get a good result there.
Really snap that piece. And this was the
okay, so now this is a segmentation label, which is different than the boxes that you had before.
Yeah.
Okay, so this is more powerful because it can enable things like copy paste augmentation.
That's right. Yeah. And this is, by the way, this is available out of the box, even if we didn't train a model. I just didn't show it earlier. Perhaps I could have. So that's the white knight. But anyway,
isn't that a white king?
Oh, you're right.
it's a
label error. I wasn't
no, but this is really interesting because a certain portion of every data set is like human error.
Yeah, I was asleep at the wheel there trying to talk and annotate. But anyway, so like you always have like this smart polygon model with like any data that you're starting to annotate. But since we custom trained a model, we can actually use that custom trained model with a label assist model. And so here like is all the list of like label assist models that I've trained.
Okay.
And so here I've like got a chess pieces model that I've already trained a version on.
Okay.
And so I could load this one from Hub. I could load this from wherever I've trained it and imported it.
Okay.
And so what this does is it loads this model to run actually completely locally and label alongside.
Oh, so this is going to run on your computer,
on my browser, in my browser.
Okay.
And run in real time and doing so. And actually, I might have mixed it up by having both of the label assists live. So I'll reload it.
So this would be a JavaScript model, right? Like a TensorFlow JavaScript model.
Exactly.
Okay.
Exactly. And yeah, so then
does this work with most browsers? Or?
Yeah.
Okay.
It does. It does. I mean, obviously, it's a little bit better when your model or when your browser or your computer. Because it's
when
running
you have a faster computer.
Yeah, because it's running,
everything's better when you have a faster computer.
Because it's running locally. Yeah, it's dependent upon the compute that your
of course that your
computer provides.
Is it memory constrained or kind of CPU constrained?
I think that most users run into issues with small RAM, with small memory.
Okay, so it could be RAM. So auto labeled models that run as JavaScript models should be smaller models.
Yeah.
Okay.
Yeah. But yeah, sorry. So, did we connect this model to send it back?
Okay, so in Hub, there's right. So if we click this button here on the right, so in the integrations tab, this is where you connect to Roboflow, and you put the slider on to send models back once they're trained automatically. So once this is on, then every model you train will be sent back and can be used for auto labeling, and I think in the future for deployment also, right?
Exactly right.
Okay.
Yeah, depending on if that's what the user wants to do with their examples. But yeah, I mean, the very first thing would be like very easy use for the iterative loop cycle. Like if I just immediately have this.
Yeah, absolutely.
But anyway, so I needed to grab my Roboflow API, which is why I went over here and grabbed my API key, and then
so you copy the private one, not the public one.
That's right.
Right. Okay.
And add that. And now
and I've connected a second workspace. Yeah.
That's right. That's right. You had it. It looks like you already had one.
Oh, this is mine. Yeah. Oh, so we've connected your workspace. Oh, in my Hub account. Oh, wow.
Yeah.
Oh, okay. Interesting. Okay.
Okay. Yeah. So
I did have one. It looks like it was called YOLO V5 Noon. I think you guys made up that name.
Yeah.
Okay.
Yeah. There's like mushrooms and stuff. But yeah, now like the models, I can like send them back and use them for continuing this iterative loop much more quickly.
Yeah. Awesome. And the cool thing is like this is really just the first step. So Hub itself is pretty new. We just launched it a few months ago, and we are still adding features and making it better. And of course, user feedback is super important there. Just like on GitHub for YOLO. I think that's what really drives us, to know what the users want, what their pain points are, and to try and match that with what we can do. So I'm pretty excited to see where this goes. And I think like the seamless nature is really appealing.
One of the things that came up in the there's a lot of questions that had come up around some of these things. One of them that came up, and I showed labeling with like segmentation, just as much as labeling with like object detection. Do you have a good sense of, this is a common question we get, of like when you might want to elect for one type of task over the other?
That's a good question. So the segmentation demos that we have look a lot better, obviously. Like the result is a lot cooler. But there are drawbacks, and the main drawback, I think, is the annotation burden. So to, I think, warrant labeling segmentation data and training a segmentation model, I think it's really something that you would not be able to do with a detection model. And so like a perfect example of this is perhaps if you are, say, manufacturing round objects, like if you are a pharmaceutical company and you are creating pills, then you want to have vision systems to automatically detect flaws in those. And with a detector, you can frame the problem that way. So if you're creative, you could train on flawed pills, and you could formulate this as a detection problem. But another way that you could do it is as a segmentation problem. And you could look at the shape of the segments, and you can take a look at things like aspect ratio and uniformity. And you can use that also as additional information or as the sole information for flaw detection for these sorts of things. So there are specific use cases that I think do demand segmentation level results, instant segmentation level results. So it's definitely a segment that we hadn't addressed before, and now we have, and I think our users are pretty excited about it.
What so you mentioned like annotation burden as one, and so I've like taken the liberty of like
trying to show. Yeah, and I realized, so this is like one of the ways that I think Roboflow is reducing that annotation burden, because obviously if we do this by hand, if we click all these little points manually, then we can probably only label maybe like 10% the number of objects that you could just with a drag and a bounding box. But with these automated tools, with this like semi-automated approach, I think this introduces like really cool options where it's taking the power of automation, putting the human in the loop to just kind of like fine tune it and correct it. And I think that combination is really powerful. I think probably fully automated solutions will always have edge cases. So I think that's really why it's important to keep the person in there. But if the person is mostly correcting mistakes rather than doing most of the annotation, I think that their effort is being utilized and exploited a little better and more efficiently. So
I think that's absolutely true.
Yeah, makes a lot of sense. By the way, I'm sure we have a bunch of questions in the Q&A.
Cool. Yeah.
Let's take a look at that here before we just get kind of like lost in our own conversation. All right, I'm going to, let's see. Okay, stop our screen share. And okay, let's see what we've got. Okay. Oh, wow. Okay, we've got a lot here. Let's see. Let me just read one of these. Okay. Okay, ChatGPT. Let's see that. ChatGPT seems to be the rage these days. Let's see. Brad says ChatGPT says there are thousands of different types of fruit. Oh, the exact number is difficult to determine because new varieties are constantly being developed through breeding and genetic modification. Do you trust that answer?
It sounds non-deterministic, but like
it sounds, it's kind of like hard to verify.
But you can't say it's untrue.
1,000 sounds like a little big, but that's definitely more than 1,000 then.
Yeah. I wonder if it's one of those things where it's like there's multiple varieties of strawberry.
Yeah, I would say, yeah, like when I go to the store these days, every time it's like a new species of apple. I don't understand.
Right.
It's just it's getting to the point where
I buy thousands.
All right, let's see another question. We've got let's see, FRA Zupi. I hope technical questions are okay. Let's see. Oh, question 3. He's got a few questions. Okay, let's start with 3. Following the previous one. Maybe we should start with 1. Okay. I'm curious about how you came up with the approach. Any feedback, comments about segmentation in general? Part 3. Oh, well, okay, this is a multi-part question. Question about segmentation. This is the first one. I've looked at the source code, and it's kind of neat how you use the boxes to get the instances classes from the mask. Assume I got it right, part 1. Okay, so segmentation is really interesting. We've done an approach where we have tremendous commonality between the detection models and the segmentation models. There's only one module that's different, and that's the final output module, which instead of being a detect module, it's a segment module. And the segment module itself inherits from the detect module. The only difference is that there's a new type of operation that creates a proto layer. Proto is it's a tensor that's 32 deep, and that means that these 32 masks, which are a reduced resolution image shape. So if your image shape is like 640 by 640, you're gonna have this proto layer, which is 32 by, let's say 320 by 320. And this tensor is responsible for every segment that comes out of the model. It can identify all the different classes, even if you have more than 32 classes, and multiple segments within multiple images. So it's really, really interesting. And the segmentation approach, of course, we didn't invent it, but I think we've sort of sprinkled our magic sauce in there to make it really simple and really integrated with the rest of YOLO. So we put a lot of effort, not just in introducing segmentation, but introducing it into a way that's just really easy to use, and that has so much in common with the existing YOLO models that the transition is really simple. So, all right, let's see a different question here. Any good heuristic for how much label per class one needs to train a fairly good detector? Okay, so more than one and less than infinite, but
okay, GPT.
And it depends on the level of augmentation you introduce. But a ballpark figure, and of course, like I don't have the correct answer because again, there is no correct answer. It's really the level of accuracy that you're willing to tolerate. So if you don't need a lot of accuracy in your application, and of course, you never want to over-engineer a solution. So if, for example, you can develop a workflow that tolerates a certain level of false positives, that's probably the right way to go rather than putting in a lot of effort into getting that long tail correct. Like taking your accuracy from like say 99.9 to 99.99 is probably a tremendous amount of effort. But if you can develop a product from the get-go, like for example, if you have 2 models and you compare the result, or 3, and then you use a consensus approach, something like that, where you are a bit fault tolerant, I think that'll go a long way. So I think like understanding like the nature of ML, how just like a person, the model will never be 100% accurate in every situation. And so just like that, like we go about our lives interacting with other people, understanding the same thing about people, that they're inherently imperfect and flawed. And our human relationships, I think, work really well sometimes. So if you can develop a product with the same understanding of AI embedded into that design that you put into it, I think that's the best approach. But to answer the technical question, I just point to COCO. So COCO has 100,000 images for 80 classes. So we're talking 10,000 images per class, or 1,000 images per class, with about 10 times as many instances per class. So for example, the right benchmark that you should shoot for to get COCO-like performance would be 1,000 images containing 10,000 instances of each class. So it sounds like a lot, which is why you can get started much more simply. But if you're developing a production system, I think that's kind of what you want to shoot for to get started. And of course, if you are heavily invested, if AI is at the core of your product, like Tesla, then you want to go much further. You want to capture millions of images and iterate on them.
That's right.
That's the most important part. The most important part isn't the first result, because you're never going to be satisfied with that. The important part is the speed of iteration, which Elon Musk has said is the limiting factor in anything. So, all right, let's see what else we got here. Someone give this man a GPU.
Oh, he wanted here. He wanted to, I know what he wanted. He wanted to see this. He would like the like now that we've got like our label or our model ready, he wanted to see it like.
Oh, he wants to see it run through
Yeah.
an auto label. Okay, let's see it. Oh wow. Okay.
So and these look pretty good.
Yeah, it's not bad. Yeah, the boxes are pretty good. Yeah.
I mean, they're representative of how loose they were in the data set itself.
Yeah.
But
this one's good.
Gonna save us a lot of time.
Yeah, it certainly didn't miss any pieces.
Yeah. Got that one. And so that's, I mean, the smart poly is pretty quick, but this is still, it saves a lot of time. So now I can add all those to my data set, and why don't I do these other 2 that I had initially too while we're here?
Okay.
And then we can.
And so again, this model's running right in the browser.
Yeah, it's running totally locally.
That's pretty impressive. It looks good.
And then those look good. I'll add this to the data set. Great. And then now we can go look at our health check, and we've got a bit more data.
It's a little healthier. Yeah. Okay.
So I got my GPU. take that comments.
Well, it looks like you guys have an answer too for how many instances you need, right? So it looks like in the Roboflow world, underrepresented
These are like
stops
ratios.
being oh, it's a ratio. It's not an absolute number.
Yeah.
Oh, okay, okay. So even if I had 1 million Black queens, it would still say it's underrepresented if I had like 10 million Black pawns.
It would be concerned.
It'd be okay. All right. Okay, so let's see. It looks like we are running out of time. Let's see if we can pick one last question here. Yeah, let's see. Okay, let's see. Here we go. Caesar David Pace. In the case of more negative samples than positive, is single class case. Okay, so negative samples and positive in a single class case. Yeah, I don't quite understand that. In a single class training for YOLO V5, you would tackle it the exact same way. And the model is going to perform much better. So just like a person that doesn't have to multitask, the less things that the model has to do, the better it's going to perform. So for example, if you had 2 classes, you could actually train like 1 model on each class and you get a better result than a single model. But I'm not sure. I think for this question, you probably want to follow the same guidelines. You want to, if you want COCO-like results, again, you want to chase those statistics. So that'd be 10,000 instances or 1,000 images. But again, it doesn't need to be something that scares you, because you can get started much more simply, as we've seen here from our chess set. Just about 20 images with a bit of auto labeling, about a minute or 2 training a YOLO V5 nano model here, setting that back for more auto labeling. And that's how you get started. So actually, and this is something that we really didn't mention too. So the iterative nature saves you a lot of annotation effort. Because rather than, for example, if you think of COCO, it took a lot of manpower to label that. But rather than label all the 100,000 images at the same time, I think a smarter approach might be to label, say, 1,000 or 10,000, train a model, use that to hybrid, man, machine label the rest of the data in increments, and just keep going that way. And that's a bit of an approach how like the student teacher models take also. Yeah. So this like creativity will go a long way in AI, I think, not just in model design, but also in workflows and iterations.
I have a question.
Yeah.
So have you seen like large language models and like GPT-3 and those sorts of things?
Yeah.
When do you think computer vision will have an equivalent? Or do you think that CLIP is already that? Or,
you know, so there's a dual nature here with what we're doing with YOLO. So the models are small, they're accessible, they're easy to train. And when you look at the language models, so what OpenAI does, I couldn't do, for example, just because the models are like too large and we don't have the resources to train those. But the interesting part for me is the crossover that's happening between the language domain and the vision domain with generative models. And I'm really interested to see where that goes. So, but again, a big motivation for me is accessibility. So like I want to create something that everybody can use, even if you don't have a lot of money for expensive GPUs. And I think the current crop of models that are coming out aren't something that kind of like students and hobbyists can experiment with. So
even if well, either pretend like Ultralytics had infinite like GPU or your OpenAI and you want to build like, what do you think that looks like of like the large vision model approach? Is it like an all-knowing object detector? Is it like a like automatic segmenter? Like you feed it an image, it can like answer Q&A about the image?
That's an interesting question. So
like Carrot, I don't know if you've seen Carrot.
I don't know, but
From DeepMind.
So Peter Thiel's idea of 0 to 1 rather than kind of like 1 to 2 is really interesting. And when you consider where AI is right now and where it's going, it's hard to tell sort of like what the black horse candidate might be for like the next leap in performance or even like leap in applications and domains. And I feel like what we're doing with YOLO is really cool. We're improving it, we're making it easier to use, but at the same time, we're not really taking the 0 to 1 leap. We are sort of going 1 to 2, 2 to 3. And it's interesting to consider the other options out there. Like what could we start from scratch, or what could we look at that other companies like OpenAI are doing with their GPT models, and how we might be able to translate that to vision? Because personally, I like vision. So that's why I'm excited to see a bit of the blending between vision models and language models. And of course, that might lead more towards a migration towards AGI basically, because what we really want to do eventually is create a model, I think, in my mind, that's able to kind of propose new physics, answer questions about the universe that we just can't do ourselves. So that's a big motivation for me. I have like a lot of questions from my physics days that don't have answers, and I'd like to see like a really smart AGI propose some answers to this one day, not today, but.
Awesome.
Yeah.
I really recognize we're over time here.
Yeah, it looks like it. Okay. So thanks for joining us, everybody. And thank you for the questions. And of course, I'm sure you have many more. You can just leave those with the YOLO V5 repo or with the Roboflow or Ultralytics forums. And yeah. Okay.
Cool. Thanks,
All right, thanks,
everybody.
Joseph.
Thanks for having me, Glenn. Appreciate it.
All right.